Welcome back to my course Industrial Biotechnology. So, today I am going to discuss a very important topic, that is the aerobic effluent treatment process. Now, as you know that there is a in India we have Central Pollution Control Board, and they made a couple of years back they made a survey that how many industry they poses the environmental pollution problem, and they identified about say about 70,000 industry that we have. Out of that, they identified about 3,000 industry, they posing some kind of water pollution problem, and these industries are mostly the chemical and biochemical industries. Now, that that question comes, how it pollute our environment. That when a industry produce kind of effluent, it goes to the water stream, and water suppose some biodegradable material present in the water stream. There are lot of bacteria present or living organism present in the water stream. They will grow and multiply. When they grow and multiply, then their population will get increased, and we know every organism, they have the metabolic pathway, they produce lot of different type of metabolites, and this organism, they are mostly aerobic in nature. That is, aerobic in nature means under aerobic condition they will grow and multiply. So, they take the dissolved oxygen that present in the water stream. So, that this is how they pollute our environment to a great extent. So, it has been observed that more than 70% of the wastewater treatment processes. So, you know that every industry here, we want to highlight that every industry, chemical and biochemical industry, they have to treat their effluent before they discharge into the water courses. So, and it has been observed that more than 70% wastewater treatment processes are controlled by the biological means. And actually, the aerobic fermentation process is a very simple fermentation process that can be easily we can easily use to safeguard our environment. I can give a very simple example. Suppose your water stream contains some kind of biodegradable organic matter. So, what is happening, your bacteria can grow and multiply very easily, and when they grow and multiply, what will happen? This soluble organics will be converted to insoluble organics. That your cell mass is an insoluble mass, am I right? And also during this conversion process, you know, every cell they respire, they convert this to carbon dioxide. So, carbon is converted into two different forms, one is cell mass, another is the carbon dioxide. So, carbon dioxide goes to the atmosphere, and the cell mass is the insoluble mass. So, that you can easily separate it out. So, if you separate it out, your water will be free from the contaminants. This is how the aerobic process works, and that is largely used by the different industry. So, today I am going to share that how this process is in operation in the industry. Now, first I want to give you the information that how this carbon energy analysis of the aerobic and anaerobic, because two type of processes we have. One is the aerobic digestion process, another is the anaerobic this microbial degradation process. So, aerobic condition and anaerobic condition. Now, here if you look at carbon balance, here 50% carbon is converted to biomass and 50% to carbon dioxide. But here in the anaerobic process, 95% decomposes in the form of biogas, which comprises of methane and carbon dioxide, and 5% only is converted to biomass. So, here 50% and here is 5%. This is the difference is there. Now, if you consider energy balance, the 60% energy is stored in the form of cells and 40% is lost in the form of process heat. But in case of this anaerobic fermentation process, almost 90% of the energy of the organic material can be recovered to as carbon as biogas, and 5 to 7% used for the growth of the cell, and 3 to 5% waste in the form of heat. So, you can see how they are different from each other. Now, the minus, because this is a very this minus mean minimum national standard. This is imposed by our Central Pollution Control Board. Now, they determine that what should be the disposal standard of the different effluent produced by the different industries. As for example, brewing industry, that it produce the whatever effluent they produce, it should have BOD 5 30 milligram per liter. Total suspended solid is 100 milligram per liter. In distillery industry, because again it depends on the kind of effluent that we have. The BOD 5 is 300 milligram per liter, because achieved by 1982, and they to be diluted with water, low BOD 5 effluent to bring it to 500 milligram per liter, used for the land irrigation particles. Now, second two-stage aerobic treatment process should be provided in 1984, so that you can bring it to 30 milligram per liter. This is kind of standard they put. The nitrogenous material, this is particularly applicable to the fertilizer industry, that pH should be 6.5 to 8, ammoniacal nitrogen should be 50 gram per liter, and gilder nitrogen is 100 milligram per liter. Now, we have complex fertilizer, woolen industry, then synthetic fiber, semi-synthetic fiber, and sugar industry. So, different as I mentioned, the different industrial effluent had their different disposal standard depending. And one thing is that when the Central Pollution Control Board, when they determine the disposal standard, they also tell you the possible method through which this can be reduced. So, otherwise it is very difficult to follow it up by the industries. So, that they keep take into account. Now, if you look at the raw water quality, that is very important, as it is determined by the WHO. But that in the day-to-day life, we take the raw water, and we should know what should be the quality of the drinking water. The pH should be 6.9. The total dissolved solid should be less than 1500 milligram per liter. Iron content should be less than 50 milligram per liter. Nitrate should be less than 45 milligram per liter. Fluoride is, I want to point out, this is very important. The BOD, the biodegradable organic matter, biochemical oxygen demand should be less than 6 milligram per liter. This is very, very important as per drinking water concept. This indicates that whether your drinking water is contaminated or not. And so this is the Indian standard that we have, that is given by the ISI, and this is the WHO standard. Now, raw water quality for drinking water with respect to chromium, then lead, arsenic, chloride, and this is the very important most probable number. I do not know whether you are acquainted with you are aware with this number. This is the indicator that whether your drinking water source has come in contact with the sanitary system. Because why? Because if you look at the sanitary system, that every human being discharges millions of E. coli every day, the pathogenic organisms, and you know that. So, if we perform the coliform test, and coliform bacterial test through which we find out the most probable number, and from that we find out that whether the water, so whatever water we are taking, it has come in contact with our sanitary system or not. Now, if the MPN number is more, that indicates that it has come in contact with that, and this is an indirect indication that it contains a lot of pathogenic organism. So, if we take that water, it will infect our system. This is a great concern. So, it should be less than 50 to 500 to 1000 per 100 milliliter of drinking water source. Normally, it should be 500 per 100 milliliter for bathing. But actually if you look at the water that is used for drinking purpose and water that is used for bathing purpose, their quality is more or less same. Now, let us talk about the different aerobic wastewater treatment processes, and first process that we come in our mind, there is a lagooning process. This is the very old process that we have. What is the lagooning process? We know lagoon. Lagoon is a kind of shallow pond. It is we put the wastewater in the shallow pond, and aerobic organisms that grow there and multiply and degrade the material. So, lagooning techniques is the natural treatment techniques which is consisted of the accumulation of wastewater in ponds or basin known as the biological or stabilization pond, where a series of biological, biochemical and physical processes take place. So, this is the lagooning process that we have. So, this is how we can explain the process pictorially. This is a shallow pond. Shallow means the height is not very, if it is high, it depends on the height, that if the height is less, then what is happening, the aerobic organism, they mostly here the aerobic organism can grow. But if the height is more, then here below this the anaerobic organism, because here there is no dissolved oxygen. So, here the anaerobic organism will grow. So, that this is how. So, usually the lagooning process is up to this, because most of the aerobic organism grow, and this is the natural process. So, the degradation would be very, very slow. Now, this is the overall overview of the wastewater treatment process. If you look at it, it's very interesting that this is the influent, because this is we take we take the material from maybe water, maybe sewage water, maybe industrial water we can take out. But this is the barred screen. Barred screen means simple barred we have, and in the barred when you put the water here, the whatever floating material is there, that will be stick on this, and so this bigger particle will be separated out. After that, you can see that the grit chamber. Grit chamber means if the particle size is more than 79 microns, that will be bigger particles that will be separated out. After that, we have the primary clarifier, where the fine particles, very small size particle about 10 micron and other things, that will be separated out. After that, this comes to the aeration basin. This is called activated sludge process. Here you allow your bacteria to grow and utilize the soluble organics and convert the soluble organics to the insoluble cell mass, and then this cell mass you separate it in the secondary clarifier. You just allow to settle. So, the solid material will comes down and clear liquid is comes in the top, and then we pass through the sand filter. This is kind of sand filter we have. Then we do the disinfectant. How we do the disinfectant? By sparging the chlorine. Chlorine, why you sparge chlorine, then all the germ that will be killed. So, we will get the pure that water. This can be used for the drinking purpose. This is how the waste water treatment process looks. That this is very simple, and in this clarification primary clarification process, sometime this primary and secondary clarification process, we use some kind of coagulants. That flocculants we prepared, these flocculants can be used, so that I can give the example of the alum. Alum is kind of a good flocculating agent, a coagulating agent. Whatever suspended material is there, that will settle down. That can be used to separate out the suspended material or hazy material. Now, one very important thing is that in this aerobic process, that we use the organism, what we call one key organism, what we call Joglia remigera. What is the speciality of the organism? The speciality of the organism is that it produces the polysaccharide gel. It produces polysaccharide gel. So, what is happening? that the bacteria, we know they are very small size, am I right? The bacteria, when it produce the gel and this bacteria produce gel, they will be sticking with each other, they will stick with each other. So, they will form a lump, they will the agglomeration of the cells take place. So, your particle size will increase. As the particle size increases, then it will settle down. Then here I want to share my experience that we have, that I did my doctoral PhD from IIT Delhi. When I did my doctorate degree there, I visited the Okhla waste treatment plant in Delhi, and there we visited their unit, and when I took the water in the activated sludge process, I found that in my hand that is big solid particle, they settle down very easily and clear water comes at the top. So, this is so nice, because so Joglia remigera is the key organism. The long has been considered the typical activated sludge bacteria responsible for the formation of activated sludge floc. This is the floc formation take place, and the generic name of Joglia has the origin of Greek language and translate the living glue. This is the glue due to the polysaccharide gel, and Joglia remigera is a aerobic and chemo-organotropic gram-negative and straight and slightly curved rod shape and non-spore forming bacteria. So, this is the key organism that is used in the activated sludge process, and the process looks like that. This is the activated sludge process, where we do little bit of aeration. How we do aeration? Here at the how you do the aeration here at the top, we use some kind of surface aerator. This is called surface aerator. Now, what do you mean by surface aerator? Aerator. What do you mean by surface aerator? Because this will throw the liquid like this. When it throw the liquid like this, the air, the oxygen present in the air come in contact with the liquid, and the lot of mass transfer take place. So, dissolved oxygen concentration in the liquid increases, and also it makes a stirring in the, so that the insoluble cells that remain in suspension, so freely interact with the liquid and produce the cell mass. So, after the cell mass production goes to the sedimentation tank, where you separate the cell. A part of the cell you can recycle back, and you will get, and some of the cell you take it out, what you call sludge bleeding, and the clear water you take it at the top, what you call clarify effluent. This is how activated sludge process looks. And this is the different that parameters we have mentioned here. This is Q0 is the volumetric flow rate. It is the S0 is the biodegradable organic matter concentration. The X0 is the cell mass concentration, initial cell mass concentration. This is the volume. V is the volume of the reactor, liquid volume of the reactor. X is the cell mass concentration under steady state condition. S is the substrate concentration, and that main drawback of the CSTR, when you have start tank reactor, your cell will go out of the system. If the amount of cell that is going out of the system is not produced in the reactor the same, then you will find the cell mass concentration will decline. So, to avoid that, what you do, a part of the cell we recycle back, so that your cell mass concentration remain uniform, so that your rate of reaction inside the reactor will remain constant. And this is how the effluent is coming. This is how the sludge bleeding take place. Now, this is the typical activated sludge process. I want to show you this here. So, here we have at the middle we have the surface aerator which is located, and we put the liquid here, and from the side we take out the effluent from this particular reactor. This is how it take place in the system. Now, the activated sludge process contain numerous bacteria and other microorganisms. When it mixed with the sewage sludge saturated with oxygen, bacteria perform the following function: oxidize the organic solid, promote coagulation, flocculation, and convert the dissolved solid, colloid and the suspended solid into settleable solids. In practice, the following operations are carried out in activated sludge process. The different operations are carried out in this process. That sewage is given treatment for the primary sedimentation tank, and then detention kept about 1.5 hours, 1 to 1.5 hours. The settled sewage from primary sedimentation tank is mixed with required quantity of activated sludge in the aeration tank. The mixture of the activated sludge and wastewater in the aerobic aeration tank is called the mixed liquor or mixed liquor suspended solid, MS or MLBS, VSS, mixed liquor volatile suspended solid. Now, here I want to point out this thing that we have come across two things, MLSS and MLVSS. What do you mean by that? Mean is that MLSS means mixed liquor suspended. What do you mean by suspended solid? It is a solid material that remain in the liquid. And what is the volatile suspended solid? It is the organic material. And we know that your microorganism is basically it is the comprises of organic material. So, the ratio of MLVSS and MLSS plays very important role. Now, suppose this ratio is usually its ratio should be 8.8. Now, if this ratio is low, suppose it is 0.5, then what does it indicate? It indicates that most of the that 50% of the suspended solid is organic. Now, if it is 0.8, we can say 80% of the suspended solid is organic. That means your cell mass will be more, and if it is 50%, cell mass will be less. So, this ratio plays very important role as per activated sludge process is concerned. Now mixed liquor suspended solid is aerated 6 to 8 hours in the aeration tank called the hydraulic retention time according to degree of purification. About 8 cubic meter of air is provided, each cubic meter of wastewater treated. The volume of the sludge returned to the aeration basin is typically 20 to 30% of the wastewater flow air supply 8 to 10 cubic meter of sludge. Now, what I wanted to stress here that we know retention time. How you can calculate the retention time? Hydraulic retention time is equal to V by F. What is F? Is the volumetric flow rate. I told you V is the volume, am I right? And volumetric flow rate means volume per unit time. So, what is happening? This is time. So, volume will cancel, this time will come. So, this is equal to time. So, and that is usually that hydraulic retention time, the how long the liquid resides in the reactor, this is 6 to 8 hours. That is the reaction time actually, that time the reaction takes place, and after that the reaction, then you take it out. Now, here since air is plays very important role, because the air oxygen, as you know, that is sparingly soluble in water, and since aerobic organism they required oxygen for the growth and metabolism, and microorganism can take the oxygen which is dissolved in the liquid. They cannot take the oxygen which is present in the air, am I right? So, that is the major bottleneck of this particular process. Now, the aerated mixed liquid suspended solid resulting in the formation of floc particles ranging in the form of 50 to 200 ppm, which is then removed in the secondary sedimentation tank by gravity settling and leaching a relatively clear liquid as treated with effluent. Typical greater than 99% suspended solid can be removed in the clarification step. So, this is the finally pass through the secondary clarification technique to get the clear liquid. The most of the settled sludge return to the aeration tank to maintain the high population of microbes that permits the rapid breakdown of the organic compounds, because most activated sludge is produced as desired in the process. Some return to the sludge is diverted and wasted sludge handling system, as I mentioned before. Now, this is the characteristics, different kinetic parameters that we have, that the maximum specific growth rate that is here is varies from 1.5 to 4 day inverse, then Qmax equal to 3 to 5, Ks equal to that saturation constant 10 to 50 gram per cubic meter, yield coefficient is 0.3 to 0.8, that hydraulic detention time is 1.02 to 1.15, d is the dilution rate, is that it is coming around 1 to 220. Then the theta c is the what you call solid detention time. Now, here I want to point it out, this is SRT and this is the HRT, that that the main purpose of the when we use any kind of suppose it is a CSTR and here you have some kind of separator, you recycle back to the system. So, main purpose is that you want to increase the solid detention time and as compared to the hydraulic detention time. Now, in case of CSTR, this will be equal, solid detention time equal to, if you do not do the recycling, then solid detention time is equal to hydraulic detention time. As soon as you recycle this solid, that means allowing more time for the solid to reside in the reactor. Now, another important thing is that food and microorganism ratio that we have, that plays very important role. The ratio that the how much there is carbonate, the biodegradable organic matter is to be converted per unit cell mass concentration. That is this is the recycling ratio and this is ml/Vs ratio, that is also plays very important role. These are the different parameters that is essential for the operation of the activated sludge process. Now, this is another very important parameter that we have, what you call sludge volume index, in the particularly in the clarification process or sedimentation process. Now, if the value is usually that value should be 100 to 200 milligram per gram. That means that sludge volume index means is if 1 gram suspended solution, this is we keep it for settling for 30 minutes, and if it occupy the volume, this is in 1 liter measuring cylinder, and if the volume is occupied 100 to 200 milliliter, then we consider it is a good settling sludge. Now, if it is more, it is not good settling sludge. If it is less, then we will find this settle very fast. So, that is also not desirable. So, our activated sludge should have this settling characteristic. It should be sludge volume index of 100 to 100 to 200. Now, one problem, the design problem I want to discuss here, that design a continuous flow start tank reactor activated sludge process to treat 0.25 cubic meter per second of settled wastewater having 250 milligram per liter of BOD5. BOD5 means biochemical oxygen, 5 days BOD5. The effluent have 20 milligram per liter of BOD5 or less. Assume that the temperature is 20 degrees centigrade, that the following condition is applicable. The effluent, the volatile suspended solids to reactors are negligible. ml/Vs, XU, ml/Vss. ml/Vss means the cell mass concentration in the reactor. This is the cell mass concentration. theta c is the solid retention time. This is the hydraulic rhythm of the reactor equal to continuous flow start tank reactor. Effluent content 22 milligram per liter of biological solid, so is 65% biodegradable. The value of BOD 5 can be obtained by multiplying the BODU. BODU is the ultimate BOD by a factor of 0.68. The waste contains the adequate nitrogen and phosphorus and other trait nutrient for biological growth. Mu d is the death rate constant of the specific death rate constant. The death rate is 0.06 day inverse and yield coefficient is 0.5. 1 day sustained peak is 2.5 times of airflow. These are the different conditions are given, and let us see how we can solve it, because whenever we go for any kind of process design, first things that we shall have to find out that what is the conversion efficiency of the process. Now, here that if you in this process what is happening, this is the input, we have 250 milligram per liter of BOD 5 and the output you have 20 milligram per liter of BOD 5. Am I right? So, it is very simple. Overall plant efficiency is like this: 250 minus 20 by 250 the 92% is the overall plant efficiency. Now, the problem is different. Now, in this this effluent is comprises of two things. It comprises of soluble material as well as insoluble material. Now, what is the purpose of activated sludge process? I told you at the beginning that whatever soluble organics is there, we are converted to the insoluble organics, because your organism utilizing the soluble organics and producing the cell mass. So, now this due to the inefficiency of the separation process, some of the cell mass might be remaining in the outgoing liquid. So, BOD 5 of the this insoluble that cell mass, that is to be detected, because this is the actual BOD 5 of the effluent is coming about 6.2 milligram per liter. This is the actual BOD 5 of the effluent. So, what is what we are getting, that conversion efficiency what we will get. So, we are getting like this: 250 minus 6 minus 2, 6.2 divided by 250, that means 97.5. This is the actual conversion efficiency, what we call biological conversion efficiency, but this is the overall conversion efficiency of the plant. This is what we have. Now, there are other parameters we shall have to calculate. First is the volume of the reactor. As you know, volume of the reactor is very important, because to carry out this process, so we know these equations. This equation, if we put different values, we can easily find out, and we find this volume is coming about 4,702 cubic meter for treating this effluent. Now, then in this process the cell mass production take place. Now, question come, how much cell mass production take place? The y observed, because we have y x by s is equal to what, that dx by ds. Am I right? But this is overall, but this is not actual the yield coefficient. Yield coefficient is the observed yield coefficient, because here we consider all cell mass, but actually only the viable cell will multiply, the dead cell will not multiply. So, you have to divide by 1 plus mu d into theta c, then it is coming 0.3125. The MLVS formation, that how you can calculate how much this actual solid material formation take place. This is the flow rate, and this is the substrate conversion take place. From that we can how much substrate is converted, and this observed yield means gram of cell mass per gram of substrate consumption. So, if you multiply it by that, we will get that how much that cell mass production is there. Now, MLVSS, the MLSS, how much that you divide by 0.08, you will get the MLSS. We find out this is the another important parameter, what you call that how much sludge you are wasting from the reactor. That can be find out that how much sludge present in the reactor, and that is equal to V into X. V is the volume of the liquid volume, X is the cell mass concentration, and how much cells we are taking out from the reactor is around theta that is that should be about QW into XU. So, this will be equal to theta c. Theta c is the solid retention time. So, this is like this, then you want to find out the QW. So, QW is equal to the theta c will come here. So, this is coming under 205.7 cubic meter per day. Similarly, we can find out the recycle ratio, that Q out by Q 0, you can find out hydraulic retention time, we can find out P by Q 0, we can calculate. Then we can, the most important thing is that we shall have to find out how much oxygen required. How you can find out oxygen required? Because first you find out how much substrate has been utilized. This here we find out how much substrate is utilized. From that we can find out that that this that means that this much of BOD, that means biochemical oxygen, that has been consumed, but some cell remain in the system. So, whatever that oxygen that cell required this oxygen for their again degradation. So, that is to be deducted to get this value. This is the ultimate oxygen that is required. As you know, the oxygen is sparingly soluble in water, and you know that then you can calculate that how much air is required in the system. That is the that you see, this is the theoretical amount of oxygen, that is the air is required, is like this. This is theoretical amount of air that is required, and we assume the oxygen transfer efficiency is 8%, then it is coming at 168 cubic meter per minute. And for design criteria, we consider 2 as the factor of safety. So, 336 cubic meter per day. So, we can calculate like this, we can calculate that how much what should be the capacity of the aerator we have in this reactor, and this is we can find out that per volume of the effluent is how much required per kg of BOD removal, how we can read it. I hope if you do by yourself, you can easily find out that how it can be solved. So, in conclusion, I want to point out that activated sludge process is a very common process that is used by the industry, largely used by the industry for the removal of soluble organics present in the effluent. So, this is very easy to operate because bacteria can utilize the soluble organisms and convert it into the insoluble mass that can be separated. Only the limitation of the problem is that you have to supply the dissolved oxygen, so that the growth of the organism should not be hampered, and we can get the maximum conversion efficiency of the system. Thank you very much.